Hello and welcome to Statecraft IAS Academy. My name is Aatif and today I am going to tell you something very interesting. Your prelims is just a few days away. What if I tell you there are certain chapters, certain areas of your syllabus that UPSC like very much? They will ask you questions from those portions every year. Yes, that's true. There are certain portions of your syllabus where UPSC will target. They will ask you from those sections every year. That is why we at Statecraft IAS Academy decided to bring you some questions, some MCQs from those very sections. Considering the previous year questions, previous year papers, we figured out a trend where we have figured out that how UPSC will ask repeated questions from those topics only. I'll explain you how that works. See, when we talk of geography, since I will bring you questions from geography only, I'll talk of geography. Geography can be broadly divided into physical geography and human economic geography. But physical geography is more important as compared to economic geography because UPSC, say if asks you 10 to 12 questions, out of 12 questions, 10 questions will be from only this section or at least 9 questions. That is why our primary focus should be on physical geography. And further, when we talk of physical geography, we can divide it. Geomorphology, climatology, oceanography, biogeography, environmental geography. Of course, environmental geography, you will study environment. That's a separate subject. But right now, when we talk of physical geography, you see, we have certain sections. And out of those sections, climatology is something from where you can expect maximum questions. Yes, that's true. I'll show you. I'll show you this thing. I've got some proof. I'm not saying anything out of nowhere. I'll show you with proof is this fact or not. I've got some questions from previous year papers. First, let's analyze them. If you look at the first question here, this one. When we talk of this question, it is clearly talking of the layers of atmosphere. Well, we're not going to solve it here, but I'm just giving you an idea how the things are. There are layers of atmosphere. It's talking of the thickness of the layers and so on and so forth. Then you come to this question, second one. What is this about? This is about isotherms. Okay, both from physical geography. One from climatology, other also belongs to the same climatology. Both belong to climatology. I hope you know isotherms and all. If we go ahead, we take a look next year, the question again from atmosphere, again climatology, how the carbon dioxide and others affect our atmosphere. Okay, just 3 questions? No, that's not the case. Then we go ahead, you can see we have one question coming from geomorphology, continental drift. This is from geomorphology. We go ahead and we see again the question being repeated as such. You see this question number 27 that I have here. It talks of the bending of isotherms in winters. The same thing that I showed you here. This one. It is the same thing again, talking of the bending of isotherms in January. It is the same thing. And these are the 2 questions that were in the 2 consecutive years, 2024 and 2025. So, if we analyze these questions, we can definitely figure out there is a trend. Okay, not satisfied yet? No problem. You can see this question as well. What is this question talking about? Atmospheric temperature. The earlier question I showed you how carbon dioxide maintains the temperature, causes global warming. Again the same question here. How the atmospheric temperature is maintained, heat absorption, greenhouse gases, carbon dioxide. Same thing. The concept is same. The wording might be different, the statements might be different, but the concept, the basic concept remains the same. Take a look at this question. The constituents of atmosphere, what we have in atmosphere. Different areas on our earth, whether temperature variations are there, why are there temperature variations, other things. So when we consider these things, we can easily conclude that, of course there are some other questions as well, but this is just to give you an idea. We can easily conclude that climatology has been very much a favorite topic of UPSC. They have repeatedly asked questions from this section. You might see a question here and there from other sections as well. For example, geomorphology. I showed you a question on continental drift. Well, there was not much from oceanography. Sometimes you might see it if it is in news, but not that much. Human and economic geography, there is hardly a question or two, maybe one question, not more. So that should not be right now your focus, because right now you should work on something that will yield you more. It's better to work for something that will give you 9 questions rather than give you 2 questions. Correct? And then other sections as well, like location based, what we call as mapping. There were some questions from mapping. You can see a question or two from mapping as well, like here. Question number 22, if you look at this is a mapping based question. And again 23, this is also a map based question. There will be questions on mapping as well, but primarily your focus should be on physical geography, especially climatology. Well, keeping these things in mind, we have decided to bring you some MCQs so that your preparation becomes better, you score more than others, and that's what we have planned for you. So join us in this series and reap all the benefits. Okay? Academy. Your prelims is just a few days away, and right now what you need is a final push. Today's class will provide you just that push that you need at this very moment. I've got some questions for you from geography that will actually help you score better than your competition. You can easily get 5 to 6 marks more than your competition. The question is based on the recent trends that UPSC has been following. So without wasting much time, let's get started. Question number 1. First of all, let me tell you something. Statement-based questions, assertion and reason questions, I hope you know it. Right now we are really near to the prelims exams. So I'm pretty sure you are aware of this. If you are not, then kindly go through the pattern once and then attempt the questions. So question number 1. Isotherms. What are isotherms? You should know. Probably you know about it. Especially the term isotherms. Because for the past 3 years, continuously, UPSC has asked a question from this very thing. That's isotherm. So read about it and answer the question. Statement 1. Isotherms show a distinct shift towards the poles over oceans and towards the equator or land during winter in the northern hemisphere. First of all, let me tell you about the isotherm. Isotherms are the imaginary lines that connect the places having similar temperatures. So this statement is asking you about the shifting of isotherms. Now, I've got a diagram for you. If you take a look at these lines that are drawn here, these are isotherms. So anywhere on this line, you will find the same temperature. It is an isotherm of minus 12 degrees. Okay? So you can see how the temperature varies. It's varying from 0 degree till 25, minus 25. Now the statement that is asked from you is, how will these isotherms shift in northern hemisphere during winters? You can probably look at this image and figure out how the shifting is taking place. This is the land mass and this is water. You should know that land masses heat up quickly and cool quickly as compared to water. It takes more time for water to heat up as well as cool down. In winters, what will happen? Because the temperatures are low, so the land masses will lose the heat very quickly and become cold as compared to water bodies. That means if we take a point here, if suppose, for example, if we have a temperature of 0 degree at this place, what's going to happen? In water, the same thing, 0 degree will be slightly northwards. Why? Because water will be less cold as compared to land. I'm talking about the winters. And it will be vice versa in summers. So that's what the statement is asking. Isotherms show a distinct shift towards the poles over the oceans. What is the shift towards poles? What is the meaning of towards pole? This is the North Pole. Yes, it is shifting towards North Pole over oceans. This is the oceanic region where you can see the line, that this line is shifting towards the poles. Every line will shift towards the pole. Every line over the water body is shifting towards the poles. Okay, So this was about statement 1. So that's correct. Statement 1 is correct. What is statement 2? Water cools faster than land due to high specific heat. This is absolutely wrong. I told you that water heats up quickly, heats slowly as compared to land and cools slowly. But it's telling you that water cools faster. That means statement 2 is not correct. So option C, that is statement 1 is correct, but statement 2 is incorrect. I hope you understood how you have to solve these questions. Well, isotherms is an important thing because you can see this question asked continuously for past 3 years. So be ready for this question this year, maybe. Question number 2. Now, it's talking of atmospheric humidity, where the concept of absolute humidity, relative humidity, humidity capacity, all these things will come into play. Statement first. Absolute humidity refers to mass of water vapor present per unit volume of air. This is correct. This is correct. Because this is a simple definition that you study, there's nothing to explain. Absolute humidity means the mass of water vapor present in a unit volume of air. Then it talks of relative humidity. First, you should know what relative humidity is and how it's calculated. Then only you can answer. It depends on actual moisture content and air temperature. You have to first understand what relative humidity is. For that, let's take an example of a bucket. Say, for example, this is a bucket of capacity 10 liters. This is the capacity of the bucket, okay? But what you're going to do is pour water in this bucket. Say 5 liters of water. We have 5 liters of water in this bucket. Now, here, when we talk of this 5 liter, this is the absolute humidity because this is the actual amount of water that is present here. Actual amount of water. So this will be your absolute one. And when we talk of the relative humidity, you calculate relative humidity by the actual amount of vapor that is present divided by the total capacity. That means you have to divide 5 by 10 and multiply it with 100, which will be 50%. Your relative humidity will come out to be 50%. What's relative humidity? Now, when you talk of second statement, relative humidity depend on both actual moisture, exactly, that's the actual moisture, how much of a vapor is present in the bucket. It definitely depends upon that. And the second part of the statement says air temperature. Does it depend on air temperature as well? Yes. Let me explain this to you from this diagram. Whenever the temperature is less, we have 50 Fahrenheit of temperature, the capacity of the air parcel to hold water is less. Okay. Whenever the temperature is less, the water holding capacity of the parcel of air is less. As the temperature increases, you can see the capacity is also increasing. We have 50 Fahrenheit temperature, then it goes to 86 Fahrenheit temperature, and you can see the yellow circle here shows the total capacity. It has increased. That means temperature affects the relative humidity. So what's the second statement? Relative humidity depend on both actual moisture content and air temperature. 110%, this is correct. So statement 2 is right. Then coming for the third statement, for the same moisture content, relative humidity decreases when temperature rises. Is this right or wrong? I just explained this to you. So what do you think? Is this right or wrong? This is again explained from the same diagram where you can see as the temperature will increase, the relative humidity will decrease and vice versa. So statement 3 is also correct. You can take your time, you can pause the video and you can answer it with patience. If you have any confusions, kindly ask me in the comments. I will get back to you and reply to you. So for the same moisture content, relative humidity decreases with temperature rises. You can see it, the vapor is the same here. It has not increased. What has increased is the temperature and vapor is still the same, but it impacts the relative humidity. So both the statements are correct. Question number 3. This is again an assertion and reason question. It is from the interior of the earth. UPSC has a habit of asking questions from interior of the earth. It has asked, so I have got some questions from you. So the first statement, The existence of a shadow zone for S waves helped scientists infer the internal layers of Earth. Well, we know about S waves, P waves. These are the waves that are generated after the earthquake. So the first statement is telling us that existence of shadow zones for S waves helped scientists infer internal layers of Earth. What is the speciality of S wave? That it will pass only through solid medium. It does not pass through liquids and gases. So, when the scientists, geographers studied the S waves, they figured out that there are some places where the S waves were altogether absent. We can see it from this image. See, this is the image of S wave. You can see these are the S waves, but this is the region where there is no S wave. So scientists could understand based on this that there are certain areas within the Earth that are not in solid state. Why? Because S waves are absent. That only denotes one thing, that is there is liquid, of course not gas, maybe gas as well, but definitely not solid. That means first statement is correct. Let's go to reason now. S waves get refracted strongly in solid inner core. Is this right or wrong? What do you think? Now, listen to me very carefully. This is the image. You can see this is core. I'm drawing this. My drawing is very bad, unfortunately, but please understand. This is the outer core and this is the inner core. S waves are stopped at the outer core. Why? Because outer core is liquid, it's not solid. That is why S waves will not be able to go through it. They are stopped at the outer core only, let alone the inner core. They won't even reach the inner core. So the statement that they get refracted strongly in the solid inner core is altogether wrong. Why? Because refraction is a different thing. They won't even reach the inner core because they have to pass through the outer core that's already in liquid state. So they cannot reach the inner core. That is why second statement is wrong. That means only A is true and R is false. Option C is the correct answer. This was our question number 3. I hope till now you have done well. These were easy questions. These are some basic questions. The levels will increase as we go ahead. Now, question number 4. Again, very important. Why? Because it talks of El Nino, and you know this year, if you are aware of the current affairs, you will be aware that year 2026 is believed to be a year of Super El Nino. What's that? You will read that from current affairs and all. But this year is believed to be a year of Super El Nino. So we can expect a question on El Nino this year. So what are the statements? It weakens the Walker circulation. It may suppress upwelling of Peru coast current. It necessarily causes below normal rainfall in India. You can pause the video and answer it. Then I will explain each and every student, and I will tell you in this very question where a student can make a mistake. And I'll show you where it's possibility. Now listen to me very carefully. When we talk of the tropical areas, we know there are trade winds that blow and they cause the up movement of the surface oceanic water. If we talk of South American coast, the water is driven from South America towards the Australian coast where it accumulates. Then eventually we can see it goes up and causes rainfall. But when we have an El Nino year, we see the trade winds are not strong enough. When the winds are not strong enough, there is not that much movement of surface water, and that impacts the Walker circulation. Well, of course, we cannot explain everything here. I hope you understood what Walker circulation is. You have read that. I'm just giving you an idea of how to answer the questions. So it will weaken the Walker circulation. Statement 1 is correct. Let's go to second statement. It may suppress upwelling of Peru coast. What's upwelling? When the trade winds take the water from here, then the water from underneath will come up. That is upwelling along the Peru coast in South America. But the fact is, when the trade winds are not able to drive the surface water away, then the upwelling will be suppressed. Why? Because you can see if the upper layer is not moving, how will the water from underneath come up? It's not going to happen. That is why you can see the second statement is correct. It will suppress the upwelling at Peru coast. So 1 and 2. Now coming to the third statement, and this is exactly where I want you to learn. Listen to me very carefully. Most of the students might make a mistake here. It necessarily causes below normal rainfall in India. Now, why am I telling you to listen carefully? Because most of the times when we talk of El Nino, we talk that it impacts the rainfall, it impacts the monsoon, it causes less rainfall. That's true. But what is the catch here? It's the word necessarily. If it was not here, then definitely it was correct. But the thing is necessarily. It is not necessary that there will be below normal rainfall in India. Why? What can be the cause? Because it's not only El Nino that impacts the rainfall in India or monsoon. You might have heard of Indian Ocean Dipole as well. If we have a strong positive Indian Ocean Dipole, then that can nullify the impact of El Nino. That can lead to normal rainfall. That is why I'm telling you, it is not dependent entirely on El Nino. So the word necessarily makes the statement wrong. If the word was not here, let's say it causes below normal rainfall, yeah, generally it causes. But in case of positive intentional dipole, it will not. So the necessary word has made the statement wrong. Just look at the keyword, that is necessarily. Okay? These extreme words in the options often make the statement wrong, but not always. So option 1 and 2, that's option A, is the correct answer. That was our question number 4. Question number 5. This is a very factual question. I think you can do it if you learned about the soils of India. This is easy comparatively. And let's go to question number 5. So what's question number 5? It's talking of black cotton soil. Black soils that are present in India. Where are they usually present? In the region of Maharashtra, Gujarat. Okay. Statement 1. It develops deep cracks in dry season. Yes, this is correct. These cracks are developed in the black soil. These are called as self-plowing soils because they develop deep cracks. So first statement is correct. Second statement. It has high moisture retention due to clay content. That's again correct. It retains moisture. Correct. Factual knowledge. It is formed mainly from basaltic parent material. This is again correct. If you have read the plate tectonics, continental drift, then you know while its journey, India moved over the reunion hotspot when it was traveling from southern hemisphere towards north. And on its journey, when it passed over the hotspot, there was volcanic eruption. That eventually led to this basaltic parentic material and formation of black cotton soil. So third statement is also correct. Statement 4, it is naturally rich in nitrogen. No, this is not right. Black soil is not rich in nitrogen. This is wrong. This is not correct. So that means statement 1, 2 and 3 is the right answer. Option 4 is wrong. So statement 1, 2 and 3 is the correct answer. Question number 6. Now the question is about jet streams. What are jet streams? What are jet streams? You know about it? Tell me in the comments. Statement first. Jet streams occur in the northern hemisphere only. Is it right? Is it wrong? We know of jet streams. There are permanent jet streams. There are temporary jet streams. But when we talk of permanent jet streams, we have two types of jet streams, permanent jet streams. Subtropical westerly jet. And number 2, we have polar jet. And the thing is that they are present in both the hemispheres, in the northern hemisphere as well as the southern hemisphere. Okay, so statement 1 is not right. Well, you can answer based on this thing only, but let's analyze the second statement as well. They develop due to differences in temperature and pressure between latitudinal zones. How do they develop? It's asking you about the formation of jet streams. Look at this image. Look at this diagram properly. This is the rising of air along the equatorial region. Then the air subsides over the subtropical high pressure. Okay, in between these two air masses, you will see the formation of subtropical westerly jet. Let me help you understand this in a better diagram. See, when the air mass rises along the equator and then it sinks near the subtropics like this. Okay, the same thing will happen again What you see in this case is, in this region, you will see a difference of pressure. Why? Because at this very level, here, there is much more bigger parcel of air that's present. For example, this is a bit complex, it will take some time, but right now we are not going into the details. Let me draw it for you. If we take this point here, what do you think? Where will be more pressure? Point A or point B? Of course, point B. Why? Because we have still a higher air parcel present here, which is going to exert some more pressure on this point. Right? Are you getting my point? I know it's a bit tricky. It will take me 1 hour to explain this thing only. I hope you read it right now. We are only doing the MCQs. But of course, the statement that they develop due to difference in temperature and pressure between the latitudinal zones is correct. You want to learn it in detail, just drop a comment. I will explain it to you. But here, let's do it. So option number D, that is statement 1, is incorrect, but statement 2 is correct. Question number 7, land breeze and sea breeze. So, statement first, land breeze occurs at night while sea breeze occurs during the daytime. Is this right or wrong? Again, the same concept that I told you about in the first question. What? The land heats up quickly and cools down quickly, while the water doesn't heat up quickly as compared to land. The same thing will apply here, differential heating of land and water. Okay, how? Now listen to me. Say this is a water body and this is land. What's going to happen? What's the first statement? It's talking at night. At night, there will be no insulation, no sunlight. What's going to happen? The earth will lose its heat very quickly as compared to water. Cold conditions will develop here quickly. Am I right? There will be cold conditions on land. And because of that, you can see comparatively high pressure as compared to water. We will have comparatively low pressure at night. This is night time. I'm talking of night time. And the wind moves from high pressure to low pressure at night. Land breezes occur at night. What are land breezes? The winds that blow from land towards water. So yes, land breezes occur at night. And what will happen during the day? When the sun will be out, during the day, what's going to happen? Let's take second case. When the sun will be out, the land will heat up quickly and warm land will have low pressure. The water will not heat up that much quickly, so it will have comparatively high pressure. It will be the vice versa. The wind will blow from water to land, and that is what is known as sea breeze, and it will happen during daytime. This is the condition at night time. This is the condition at daytime. Sorry. So statement 1 is correct, no doubt. Statement 2, land breezes are caused by faster cooling of land at night. That's exactly what I just explained it to you. Why are land breezes caused? Because the land cools quickly as compared to water, and that leads to land breeze. That is statement 2 is also correct. Statement 3, sea breeze bring warm air from the land towards the sea. It's telling you that sea breeze brings warm air from land towards sea. Why will a sea breeze bring warm air from land to sea? It's not going to happen. Sea breeze is a wind that blows from sea only. So this is wrong. Option 4, land breeze generally results in cloud formation over the seas. Is this right or wrong? This is correct. Why is this correct? Because let's take an example. When the cold wind blows from the land over the water body, this will cause the warm air to rise and eventually lead to formation of clouds. So option 4 is correct. Hence, we have three statements here that are correct and 1 is wrong. So that will be your option C. Only 3 are correct. I hope you're doing good right now. We have done 7 questions and I'm expecting you to do good, at least do 6, if not 7. Now, we are talking of question number 8, global temperature variation. We have got 3 statements and you have to figure out which statement is correct and which statement is not correct. Please take a look at this while I have a sip of water in the meantime. Okay, let's start. Statement 1, the annual temperature range is higher in continental interiors than in the coastal regions. We know it. This is right. Why? Because in the interior of the continents, it's called continentality as well. What happens is we have intense temperatures. Summers are extremely hot, winters are extremely cold. There's an example, you can talk of Delhi and Mumbai. You can see there is not much difference in Mumbai. You can have temperature go around 36 degrees, sometimes it's more, but around this region only. And it goes down to maybe 25 degrees. But in Delhi, you can see the temperature sometimes cross 40 degrees. And in winters, it goes down to 2 degrees. So there is a huge difference. The annual temperature range is more in continental interiors as compared to coastal regions. This is correct. Now, statement 2. Polar regions experience greater seasonal temperature difference than equatorial regions. This is also correct. Why? Because in equatorial regions, we have kind of moderate temperature. There is not much variation as compared to polar regions where the temperatures have a lot of variation. This is a factual information. You should know about it. There's not much you have to understand. Now, statement 3. At the same latitude, eastern coastal areas are warmer than western coastal areas in winter. What do you think? Use your brain. Why I'm telling you to think about it is because this is the very tricky statement. If you get such a statement in exam, you can easily mark it wrong. What do you think of it? Listen to me very carefully, very carefully. Look at this diagram. Let me draw, first of all, let's say this is the Tropic of Cancer, and then we have Tropic of Capricorn. Okay, this is Tropic of Capricorn. What we do is we don't understand the statement properly. It is not talking of any specific region. It's not telling you about the tropics or the temperate region or the poles. It's just asking you in general. The eastern coastal areas are warmer than western coastal areas. So basically, what are the eastern coastal areas? This is the eastern coastal area. This is the eastern coastal area. This is the eastern coastal area. Okay, this is the eastern coastal area. So it's telling you that in general, these areas will be warmer as compared to the western. That's partially true, not fully. Why? Because when we take a look at trade winds, we know we have easterlies in the tropics. What they will do is they will drive the surface water, warm water, towards the east coast. So the warm water will accumulate near the east coast of the continents. Am I right? Along the east coast, we will have warm water. And warm water will eventually make the conditions a bit better. The temperature will be slightly higher. Is that what it's asking you? Eastern coasts are warmer than western coasts. So first part is okay, what I told you, but there is a twist. What about the rest of the planet? Not the tropics. Okay, in tropics the statement is true. In tropics the statement is 100% true. But when we look at the extratropical area, what happens is we have westerlies here. Westerlies will drive the water in this direction. And you can see in these regions we will have warm western margins as compared to eastern margins. That is why you will see we have frozen conditions in Canada and all, but slightly better conditions in UK. Why? Because we have accumulation of warm water. Of course, there is a role of ocean current and all, but this is a generalized thing where you have to understand that this thing, whatever is said in this statement, applies only to tropics and not in the temperate areas. So this statement is wrong. Yeah, there's one more thing. If the statement was written as the same latitude, eastern coastal areas are warmer than western coastal areas in winter in tropics, then this would have been correct. Because in tropics, this holds true. But when we talk of the extratropical areas, the temperate regions, it is the vice versa. That means statement 3 is not correct. Only 1 and 2, first two statements, option A, 1 and 2 is the correct answer. I hope you understood this. Now, question number 9 is talking of earthquakes. With reference to earthquakes, consider the following statements. What are the statements? Earthquakes occur due to sudden release of energy along the fault lines. Yes, that's the definition of earthquake. That's the formation why the earthquakes take place. Because the energy that's trapped within the earth, when that is suddenly released along a fault line, that leads to an earthquake. That means statement 1 is correct. Now statement 2, S waves travel faster than P waves. Is this right? No. P waves travel faster than S waves. But here it's telling us about S waves being faster than P waves. That's not right. P waves are comparatively faster as compared to S waves. That means statement 2 is not right. Okay? Now, coming to statement 3. The point where the earthquake originates inside the earth is called the epicenter. Is this right or wrong? This is also wrong. It's not called epicenter, it's called hypocenter. Look at this diagram. This is where the earthquake originated, where the energy release took place, and this is known as focus, or you can name it as hypocenter. Then what is epicenter? Epicenter is the place on the surface of the earth nearest to the focus. The nearest place on the surface of earth to the focus is known as epicenter. So epicenter is not inside, it's the place on the surface. Are you getting my point? So that is what I'm telling you. The point where the earthquake originates is not called epicenter, it's called focus or hypocenter. That means third statement is also incorrect. So option 1, that's option D, is the correct answer, 1 only. I hope you're getting what I'm trying to say. Just remember these terms, hypocenter, epicenter, all this. We get confused in the exams when we take it very lightly. Question number 10. Now, what's question number 10? Which one of the following statements correctly describes the Earth's mantle? We know about the layers of the Earth, at least the broad classification, crust, mantle, core. So it's talking of mantle. It's given you 4 statements and asking you about which of the following statements is correct. Option A, it extends from Earth's, this is probably the easiest question. It extends from the Earth's surface to a depth of about 2,900 kilometers. What do you think? Mantle extends up to 2,900 kilometers, that is true, but it is not from the surface of the Earth. From the surface of the Earth we have crust. And it's telling you from the surface of the Earth. This is wrong. This is not right. Read the statements very carefully. Just don't look at this 2,900 kilometers and just mark it as correct. That will be wrong. Option B, it lies entirely below the lithosphere and above the core. Yes, that's true. It lies above the core. But is it entirely below the lithosphere? UPSC has asked a question on this as well. Look at this diagram very carefully. This is the region of inner core and this is the region of outer core. Then we come here. This is mantle, lower mantle. Then we talk of upper mantle. It's divided in certain parts. But when we look at this region, here, this is also part of mantle that starts from here. The mantle starts from this line, from where the mantle starts. But when you take a look at lithosphere, it includes some part of mantle as well. Not only crust, but some part of mantle as well. And what it's telling here is that it lies entirely below. No, not entirely. It includes some part of lithosphere as well. So that means this is not right. Wrong. So what exactly is mantle? Mantle is the some part of lithosphere. Okay. Then we have other things as well that include the asthenosphere and all. So we should take care of those things. Okay. So this will be wrong. It constitutes the largest share of Earth's volume among all the layers. This is something that you should know. This is 110% correct. The mantle is actually the Earth's volume maximum that lies in the mantle. It is composed predominantly of silica and aluminium. Again, wrong. Why? Because mantle is not Sial. It is Sima. Sima. S-I-M-A. Magnesium we have here. So option D is wrong. Only option C. It constitutes the largest share of Earth's volume among all layers. Option C is the correct answer. Question number 10. Question number 11. Regarding temperature inversion, consider the following. You know what's temperature inversion? Normally what happens is when we are on the surface of Earth, the higher we go, the cooler it is. Temperature falls with 6.5 degrees per kilometer. That is normal lapse rate. As you go higher, the temperature will fall to 6.5 degrees per kilometer. But when we talk of temperature inversion, what happens in this case is as we go higher, the temperature will not fall, but it will rise. Am I clear? Now, let's look at the statements. It is commonly observed in valleys during winter. Is this right? Yes, this is true. In valleys, you will see temperature inversion. Why? Because when we take a look at a valley, for example, this is a valley. What happens in winters is that at night, these areas cool down. The top of the mountains will cool down. They will lose heat very quickly. And the air will start to come down, pushing the warm air up. The warm air will be pushed up and the ground floor, sorry, not the floor, my bad. The ground will be occupied by the cold area, the cold air, and the layer of warm air will be formed. That means we will have a warm air over the cold air. That's exactly what the temperature inversion is. It is commonly observed in valley during winter. Yes. Option second. This is correct. Okay. It helps in trapping pollutants leading to smog formation. Again, this is correct. Why? Because when we don't have any kind of inversion, what happens is that the air circulates, the pollutants are taken away by the convection. But in case when we have a warm layer above it, the cold air will not rise up. Why will the cold air go up? It's the warm air that rises. Cold air will not rise. So that means we will have a warm layer here. Are you getting my point? And it will prevent the pollutants from escaping, which will eventually lead to smog formation. So this is also correct. It leads to convective instability in the atmosphere. This is wrong. Read the statement properly. It leads to convective instability. If it would have been stability, then it was right, but it leads to convective stability, not instability. You know what stability and instability is, okay? So I hope you know about it. So it leads to stability and not instability. Third statement is wrong. Take a look at this image. This is a normal condition in which we have warm air. As it rises up, then it cools and eventually causes rain. Right or wrong? But in case of this temperature inversion, the cold air is under the warm air. So why will the cold air go up and cross this barrier? It doesn't need. So this is the condition of stability and not instability. So option C is wrong. That means option A, only 1 and 2 is the correct answer. This was question number 11. Question number 12. Now, this is a applied question where you should have knowledge of the temperatures of various places. A meteorological station records high temperature. You know what a meteorological station is. I hope you know about it. A meteorological station records high temperatures, intense evaporation, and afternoon showers almost daily throughout the year. Throughout the year, what you're saying is we have high temperatures and then rainfall in the afternoon. Talking basically of convective rainfall. What's convectional rainfall? You know what that is. Okay, now listen to me very carefully. It's asking you about which kind of climate is it. First statement, influence of mid-latitudinal cyclones. Mid-latitude cyclones, we call them as extratropical cyclones as well. Okay, will there be extratropical cyclone that's going to impact this kind of a weather? No. Why? Because this is a situation that will take place in the tropical areas. This is a weather condition of tropical region. And why will there be an extratropical cyclone in a tropical region? Why will that have an influence in the tropical region? There will not be any the mid-latitude cyclone in the tropical region. So statement 1 is not right. Presence of intertropical convergence zone, this is right. When we talk of equator or any other region, this is where this kind of a temperature is, where we will have 30 degree, 35 degree temperature and we will have constant rainfall. Am I right? So this is very important. This is the presence of intertropical convergence zone under such conditions. Then statement 3, strong convectional currents triggered by high insolation. That's what I told you. Under such conditions, we will have insolation, sunlight, which causes the convection or the rise of air, eventually causing rainfall. That is why we have daily rainfall in the afternoon. Till afternoon, we have the convection of air. The air rises and then that leads to rainfall. Are you getting my point? If I was once upon a time, I was in Bangalore, and you could see there, if you are from Bangalore or any other region, so you will know about it. In Bangalore, I observed something. Every day, almost every day, there was rainfall in the afternoon at around 4 o'clock, 5 o'clock, every day. That's what it's talking about. So statement 3 is again correct. Presence of intertropical convergence zone is there. Strong convective currents are also there. That means 2 and 3 is the correct answer. Okay? Option B. That's 2 and 3 only is the correct answer. I hope you're getting what I'm trying to say. Now we come to the layers of the atmosphere. Consider the following statements. You are given 3 statements. There are 3 statements. Read carefully. Up until now, we did the questions with 2 statements. Here, we have 3 statements. Statement 1. The temperature of troposphere decreases with altitude. Is this right? The temperature of troposphere decreases with altitude. This is right. That's what we call as normal lapse rate. What I told you, 6.5 degrees decrease in every 1 kilometer. Statement 1 is correct. Statement 2. The troposphere derives its heat from terrestrial radiation. Is that right? That's again right. You might have some misconception here that our Earth or the troposphere gets heated because of the incoming solar radiation. That's not true. Earth is not heated because of incoming solar radiation. It is heated because of the Earth radiating back the long wave radiations. The radiations coming from the sun are short wave. They do not heat the atmosphere. The atmosphere gets heated because of the long wave radiations that are radiated by Earth. The troposphere derives its heat from terrestrial radiation. This is again true. Statement 2 is also true. Now coming to statement 3. The lower atmosphere is largely heated by absorption of incoming short-wave solar radiations. I just told you just now that no, the atmosphere is not largely heated by the incoming solar radiation. It is heated by the Earth radiating long-wave radiations. Incoming solar radiations do not largely heat the atmosphere. So statement 3 is not correct. Well, you can have some confusion here that Earth gets heated because of the incoming solar radiation. No. It is heated because of the outgoing long wave radiations, terrestrial radiations from Earth. That means we have statement 1 and 2, they are correct, but statement 3 is not correct. So what should be the answer? Look at the options carefully. Statement 2 and 3 are correct. This is wrong. Why? Because 3 is not correct. Statement 2 and 3 are correct. Again, no. Only one of the statement 2 or 3 is correct. Yes, that's true. Only one, that's only 2 is correct. Is correct and explains statement 1. Does it explain statement 1? What do you think? It precisely explains statement 1. Why? Because when the Earth radiates it, most of the heat will be at the lower levels, and as we go higher, there will be less heat. That is why there is fall in temperature. That means option C. Only one of the 2 is correct and it clearly explains statement 1. Make sure you read the options. These are the questions that have been asked here. UPSC has asked such questions. So you can expect this kind of a question. Please make sure not to miss such a question. Should not. Question number 14. 3 options. You have to tell how many of these are correct. Option first. Fold mountains and then force responsible for formation of mountains is orogenetic force. Second, continent building, use static force. And then third, balancing of landforms, isostatic forces. What do you think? How many of the statements are correct? How many of the pairs are correct? Now, let's look at it one by one. Fold mountains, are they formed of orogenetic forces? Yes. We have 2 types of diastrophic forces, orogenetic and epiorogenetic. Okay, these are the two kinds of forces that operate. Orogenetic forces operate like this, and which leads to formation of fold mountains. This is right. Continent building is not because of eustatic forces. No, not at all. They are because of the epiorogenic forces. Remember this. Continent building is because of epiorogenic forces. This is the up and down movement. Okay, up and down movement, and that is why statement 2 is not right. Now, statement 3, balancing of landforms. This is because of isostatic forces. Isostasy basically leads to the balance that is maintained on the earth. Whenever the isostasy is disturbed, you will see earthquakes. For example, you might have heard of the big dams constructed by China. And most often than not, you will see earthquakes associated with that. Why? Because in those cases, isostasy is disturbed. So you have to take care of isostasy as well. And yes, that is responsible for balancing of landforms. So this is correct. But option 2 is not correct. Continent building is because of epiorogenic forces. That means only 2 pairs are correct. Only 2 are correct. Okay, let's go to question number 15. Consider the following pairs: Moho discontinuity, Gutenberg discontinuity, and Lehman discontinuity. These are discontinuities. If you have studied the interior of the earth, you know there are discontinuities located between different layers of the earth. Conrad discontinuity, Moho discontinuity, Gutenberg, Lehman, all these discontinuities are located within the earth. So are they correctly matched? Okay, let's take a look. This is the interior of the earth and showing the discontinuities. We have crust. Okay, and there is a discontinuity called Conrad discontinuity between upper and the lower crust. Okay, we have CC, you can remember CC, upper and lower, and then C, Conrad. Okay, this is easy. Now, as we reach from lower crust to upper mantle region, we have a discontinuity called as Moho discontinuity between the crust and mantle. So what was this? Statement 1, Moho discontinuity, or your Mohorovic, you can call it. It is between crust and mantle. That means option 1 is correct. Okay. This is upper mantle, and then we have lower mantle. In between these two, we have a discontinuity, that's repeti discontinuity. Between mantle and mantle, we have repeti discontinuity. Clear? Now, coming from lower mantle to outer core, this is the outer core. Between mantle and core, we have Gutenberg discontinuity. Between mantle and core. Now, what is statement 2? Between outer and inner core, Gutenberg. Is this correct? Tell me. No. Why? Because it is between mantle and core. So, statement 2 is wrong. Then we go from core to inner core, outer core to inner core. There is one more discontinuity, that is Lehman discontinuity. Between outer and the inner core, we have Lehman discontinuity. When we look at the options here, you can see Lehman discontinuity and it's mantle and outer core. That's again wrong. How is it wrong? It should have been like this. Option 3 would have been matched with this. Option 2 would have been matched with this. Then it would have been correct. But these two are not correct based on the diagram that I have shown you. So you should know about it, that only one of the 3 is correct and all others are wrong. I hope you understood this. Now, listen, you might get confused sometimes which continuity is between what. I'll give you not a shortcut or something, but just to get some idea. I used this when I was not able to remember them. Then when you have C and C, that's crust and crust, then you have a discontinuity that starts with C, Conrad. Okay, C and C, you have Conrad. Then you have crust and mantle. So you have M here, M will start with M, that is Moho discontinuity. Very important. Remember this one at least. Then when we have M and M, it's repeating. Why? What is repeating? M and M, it's repeating itself. Okay, you have M and M. So this is a bit of a, not a mnemonic or something, but just to remember things. This is the option 1, only one of the following is correct. I hope we have reached to question number 15, and I hope at least 10 to 12, these were easy, these were not that tough, at least 10 to 12 questions you're done. I think we should stop here. What's the time? Yeah, I think we can stop here now, and we will most likely bring one more class with such questions so that you can score better in your prelims. Till then, work hard and all the best. See you soon. Bye-bye.